you need to have several ways of distinguishing between exothermic and endothermic processes. So we're studying here whether energy flows into a chemical reaction or whether a chemical reaction produces energy or energy flows out of the chemical reaction. That's what we're looking at here. So here's a reaction that's many of you have seen, where we take liquid water, and we can see that it's in the liquid state because we have an L here, and we run an electrical current through it. So we would call this electrolysis of water. And the water splits apart in the process of electrolysis and produces hydrogen gas and oxygen gas, as seen in the equation. Now, if we were to disconnect one of these wires, this reaction would stop. This reaction requires a constant input of energy. That's why it is classified as an endothermic reaction. Energy goes in. Well, there's another way of recognizing this as an endothermic reaction that you need to understand, and it has to do with a graph. If we were to make a quick graph of the reactants and products in this reaction, and where we were to compare the energy that is contained in those chemicals, within the chemical bonds, within the electrons, within whatever it is that produces energy, we're looking at a scale on this axis of energy, and we're just seeing the reaction occur along this axis. So I'm just going to make a line here representing this amount of energy as the amount of energy that's contained in the water molecules in the sample. Now, what do we do to make this reaction go forward? Well, to make this reaction go forward, we have to bring energy from somewhere out in the surroundings, and we have to put energy into the system. Now, the amount of energy that goes in, we can indicate because we see that after the reaction, the products are at some higher level of energy. There has been an input of energy, so now the oxygen gas and the hydrogen gas have more energy. So this is characteristic of an endothermic reaction. Energy is input into the system, and the products that we see up here, the products have a greater energy. Now, one way we can indicate to you that these products up here have more energy is that if I take a test tube and put into that test tube hydrogen and oxygen and put a light to it, put a spark to it, that energy is going to come back out. If we reverse this reaction and take the hydrogen and oxygen and make water, we will get that energy out. But in an endothermic reaction like this, the products have greater energy. And you can see that in this particular graph. Now let's consider for a moment exothermic reactions. If you take a small piece of calcium metal and you place it on a petri dish, this calcium metal is a gray, silvery chunk of stuff. And if we add some water, we see it starts to bubble, and then a big cloud of steam rises because it releases so much energy. It also releases calcium hydroxide. Well, not as a vapor. There's calcium hydroxide left behind in the water that actually is dissolved in the water. We call that aqueous. And our good friend, hydrogen gas, is here as well, is produced. Now, it's obvious when you see this that it's a reaction that releases energy. So if we are to make our graph where we have our reactants as calcium and water, these are the things that react. And we're graphing once again the energy involved in this reaction. Because there is so much energy released. Now keep in mind this energy is leaving our little system of reactants. The energy is going out. Energy out. That's why we call it an exothermic reaction. The energy is exiting. So as a result, the products of this reaction, the calcium hydroxide and the hydrogen gas, have some lower amount of energy than we started with. So in exothermic reactions, where the energy is released by the reaction, in exothermic reactions, the products have less energy, that's a G, than the reactants. So hopefully there are a couple of ways now that you could look at a graph of the energy involved in a reaction, or you can look at the reaction itself and decide, is this exothermic or endothermic? Hopefully you could also go back and look at a reaction and recreate one of these graphs.